Ahí, ahí le di Start Streaming. I was muted. Hello everyone. Now, Mati here. And I wanted to welcome you to a new edition of the Java Code Camp. If you like coding, you are in the right place. So, today we're going to be learning about this technology called Docker. And many of you may have heard about Docker. Many of you may not have heard about it. Maybe you heard about it, but you never used it. So this is a great place to start learning about Docker. So thank you everyone for joining. My name is Matias Salerno. I work in Globan. I've been in Globan 11 years now. I'm a subject matter expert and I'm passionate about coding and technology and learning new things. So I hope you in these two sessions about Docker, we'll learn together how we can use Docker, this great tool that will make your life easier as a developer. And also, it is crucial to understand what is the concept behind Docker, because it's a great tool that is being used everywhere now. So welcome everyone, and let's get started. So the first thing we're going to do, and let me know if you see. Now you should be seeing my screen, and what we're going to be doing, just give me a second. Something is not right with the camera, but I'll fix it in just a second. So here. Now you should be able to see me. All right. So we were saying that Docker is a great tool that will help you not only create applications that you can deploy in the cloud and you can run everywhere, but it can help you a lot also in your local environment development. So let me introduce you a little bit to Docker. All right, what is Docker? Docker is a platform for developing, shipping, and running applications in isolated containers, simplifying the deployment and scaling across various environments. Right, so there's a lot to unpack there, a lot of concepts, but we're going to go through the different concepts. So let me just go ahead and let me know if you're hearing right. I've been having some issues with my internet today, but I think everything is working fine now. So just let me know. Yeah, I was just checking that. So, all right. We are talking about the main concepts around Docker, okay? So we'll go with the first concept, which is the container. What is a container? In Docker, a container is a lightweight, isolated environment that packages an application and all their dependencies. Let me give you an example. If we have a Java application, you know we need the Java virtual machine to run that application, right? So every Java application runs on a Java virtual machine. So if you want to run a Java application in your local computer, you'll need at least that. You'll need the Java virtual machine on top of the operating system. So a container is a very lightweight virtual machine. So it's very thin. It doesn't have a lot of things. It just has whatever the application needs to run. So a Java application will need a simple operating system, and then it will need the Java virtual machine. So if you have those two things, you can actually run a Java application. So if we want to if we want to so that's what we mean by dependencies. We will have a Java application, a jar file, for example, and then we'll have the Java virtual machine also in the container, and that will be run as a lightweight virtual machine. Then we have the concept of images. So what is an image? An image is a template that contains the application, the code, and all the dependencies that we need to create a container. So it's like the recipe for your container. It's where we can say, okay, this image, if I create containers using this image, the containers will have a particular Java application, and they will have a Java also running on the container. So basically, you can create new images, and those images you can extend them by using a Docker syntax, which is really useful, and we'll talk about it now, which is the Dockerfile. The Dockerfile is a script file. It's a code that we can use to create new images. So it's some sort of a, you can declare things that the image will have. For example, you can declare that your image will have Java. You can declare that your image will have yes, it will have Java, and then it will have also the jar file that you need to run that application. And then you can also declare in your image which command you will use to run the Java application, and so on. There's a lot of things you can do with the image, with the Docker file. And today in our tutorial, we're going to create a new image, and we will run a container using Docker, the Docker file. And then we have the image repository, and this is where we store images that we want to store for reusability. So if we create an image with Docker, then we can push that image into a centralized repository, and everyone can use that. Everyone who has access to that repository will be able to use that image. So and that is a great thing about Docker, because it allows me to run the same container in multiple machines. You just need to have Docker installed. And by the way, if you want to follow along this tutorial very well, I recommend you to install Docker right now. Go into docker.com and just download Docker. It's going to be very easy but yeah, you will need Docker to run this tutorial. So then, all right, so with the image repository, you can share images with different people, and then you can synchronize it and run containers in multiple computers. I'm looking at the comments there, and so everyone's saying hi. So hi everyone, thanks for joining. All right, so here's how we can see the concepts of Docker in action. We have the Docker file, which we said is like the template that the script language that we will use to create an image. So with the Docker file, we build that file and we get an image. That image is stored in our local Docker repository, which is a similar thing like a Git repository, right? But it's for images. Once you have that in your local repository, you can either run it, and if you run it, it will create a container. So it will create a virtual machine in your laptop, and it will run the container. So it will run the application and so on. Then you can push that that image, you can push it to a centralized image repository, and then other people can pull that image and run the same container. So the great thing about this is, for example, let's say you need a particular version of Java to run this container, right? To run this application. So you package your application with Java, and anyone can run that container if they have Docker, and it doesn't matter if they don't have Java. And this is great for big applications as well. Like for example, with this you can run databases in your in your laptop. You can run, for example, message brokers like Kafka, RabbitMQ. Everything has Docker images that are public, and you can just pull them and run them so that you don't have to actually install that. And it's very convenient when you have to deal with multiple versions of it. For example, uh, if you are working with multiple projects and you have, let's say, one project is very old, so it uses MySQL 5, and then there is a newer project that uses MySQL 8, and you want to install both in your local laptop, it's really hard because sometimes those can get in conflict with each other. So with Docker, you can actually you can pull that image, run a container, then destroy that container and create a new container with the newer version. So it's fantastic for that. So what are the advantages of using Docker? First is the portability. As we were saying, we can run applications in multiple places without almost any issues. Isolation as well. Applications become isolated, so they don't really uh, they can be secure in a better way, and they're very stable. Efficiency. So if you have a system that has shared resources, then it becomes really efficient to create new containers. For example, in a cloud environment, containers are used a lot because they're very easy to start and stop. Because they're way more lightweight than an actual virtual machine. So it's really easy to do that. And because of that, it's very good for scalability. The other is version control. So you can actually manage the different versions of an image. So when you create new images, you can version them so that it's easy for you to know exactly which image you're running and what are the characteristics of that. Rapid development, rapid deployment. As I said, it's really easy to start a new application running on a container because the container is a very rapid, a very quick uh, virtual machine. For collaboration, it also simplifies this because of the standard. You also everyone uses the same container, the same images, so it really helps standardize the development around the whole team, across the whole team. Then it has a great ecosystem. So there is multiple places where you can download Docker images. Docker Hub is the most popular Docker repository that is around. There is open source images for anything, any kind of software that you can imagine. You will have continuous integration. Also, is Docker is used a lot in continuous integration to run tests on applications. So you can start an application, then run tests on it, and then you can tear down the containers. Really easy to do. And it's cost efficient as well. So because you can tear down and start new containers very quickly whenever you are not using your application. Maybe there is not a lot of users for your application, then you can have less amount of instances, less amount of containers running that application. So it's really efficient in that sense. All right, so here's our tutorial, and in our tutorial, what we're going to do is we're going to have a Spring Boot application. Well, I hope most of you might be familiar with Spring Boot. We'll have a Spring Boot application, and we will create a Docker file for that Spring Boot application, and then we will build the image we will run the image in a container, and then we will also push that image into a centralized repo, which is the Docker Hub. And then we will uh, run this image, or at least we'll try to run it on Microsoft Container Apps. So this is an image, a container orchestration tool that Microsoft has on the cloud, and you can sign up to it. It's really easy, and it has a free tier so that you can use to test these kind of things. So I'm going to show you. Doesn't matter if you cannot do it, you don't have to for this tutorial. I just want to show you the power of Docker and how we can use Docker to actually run containers anywhere. And I could run them in Microsoft, or I could run it in AWS as well. So this is really, really useful. But you will also be able to pull this image from your laptop, and you will be able to run it in your local environment. So let's see. So that's what we are going to do. All right. So I have our application here, and let me just I think I haven't shared. Let me see if I can share with you the actual code. So this is GitHub, right? And in here, so I'm going to be sharing this this code on the chat. Let me see if I can do it. So you should have got that link over there, right? So that link is the repository that I'm using as a base, and I'm going to start by testing this application. Okay, so let me just walk you through this application a little bit. This application is a REST application that returns a list of books. Okay, so we have 3 books, and we have a book controller that has an endpoint. It has a get endpoint. So I'm going to call this get endpoint. So every book has an ID, a title, and an author. And I'm going to call this get endpoint. It's really simple. It's a simple application. So I'm going to run this as we would run it in a Java, as a Java application in my local environment. So this is not running on Docker or in an image or anything like that. So I'm going to run it here. I'm going to say localhost 8080/books, right? And here we have the books. Okay, so we have 3 books in our tutorial, and it's really, really simple, very simple application. Okay, so I'm going to stop this application now because we have tested it. It runs, it's fine. So now we want to actually build this application. Sorry, we want to create a Docker file for this application. So to create a Docker file, I have here. So let me just going to move this right here. Okay. So to create a Docker file, we'll just go here and we will say new file. We'll say Dockerfile. Okay. and this will be added automatically. So now that we have a Docker file, I will show you a little bit about the what is it called? The syntax of the Docker file. So the first thing that you would do in a Docker file is say, okay, I want to extend a particular image. So for example, this is a Spring Boot application. It's a Java application, and I need Java to run it. So how do I run this? I would say from. So how do I say, okay, extend a Java image? And I would say open JDK 21. So this is an existing image that we have available in Docker Hub. And this image is a base image that you can use for any Java application, which will run Java 21. So with this image, you will be able to run any application that requires Java 21. So now that we have Java 21 in our image, we can tell more things to this, to the Docker file. So our image, our application, as you have seen, our application runs in the port 8080. So we need our container to have the port 8080 exposed. So I'm going to tell that to the image. I'm going to say expose 8080. Okay? Very simple. So now what else do I need? I would need, if I want to run a Java application like I did here, I actually need a jar file, for example. So I would need to create a jar file to and then add it to that image so that I can actually run this. So I'm going to say, so I don't have a jar file here. I need to build this application. So I'm going to build it using Maven. I have Maven here, and I can simply say here, for example, I can use package. Okay. So now Maven is building this application. And once it builds, it will generate my jar file. Okay, so now I see here in the target folder, the target folder is where Maven stores every output of the runs. For example, you'll have multiple class files that were generated, and then you'll have sources and many things, the test reports. But what we want is this, it's a jar, right? So the jar name is this one. So what I have to do here to add the jar, this jar, into the image, I have to do add, and I can access target there and Spring Docker like that. So now this is adding the application, and now I just rename this to maybe books app.jar. Okay, so this is basically copying the jar file into the image, and finally we'll have to use this entry point command. And this entry point command, what it does is it will tell me which command do I have to run for my application to actually start. So as this is a Java and Spring Boot application, I have to run the command Java, and I will also say -jar because I'm running a jar file. And finally, books app.jar, the name of the jar I want to run. Because I have this jar here, I can run it. So this will run my jar file. So this is what it's going to do is it's going to start the container. The container will run this, and it will automatically start running the Java application. So the first thing, remember, the first thing that we'll have to do is build our image. I don't know if there are any questions. I'm looking at the questions here in the chat, but I don't see any questions. So far, so good, guys. Let's see. No, I don't see any questions. Okay. If you have any questions, just shoot, because I can answer questions as well. So, all right. I was saying we have to build the Dockerfile using a command called docker build, and then we will have to run that image that we created. So let me quickly show you how we can do this. I'm going to open a new terminal. Okay, so I have a terminal here, and I'm going to run this command called docker build dot, because the dot here is saying where is the Docker file located. The Docker file is located in this folder, which is the dot folder. So because it's located in the folder that I'm on right now, I can use like that. And then I'm going to add a tag to my image like this. So this is going to create an image by compiling the Docker file. Okay, so let's try that. Here we go. Just have to wait, but if there are any questions, just let me know. We'll have to wait a little bit when we're building this kind of things. Okay, it was really fast. So I could do docker ls. Sorry, docker. What was the images? Docker image ls. Right. So if I do docker image ls, I can see you'll see I have a lot of images right here, but the last one, we should find someone called book app somewhere. Book. Trying to find it. Yeah. Oh, here it is. So we have books app here, and it was created 24 seconds ago. Here's my image ID. So now we have an image, and we can run this image. So I'm going again to the terminal. I'm going to clear this a little bit, and I'm going to run docker docker run, and here the p argument is going to tell Docker where do I want to I want to expose this container in a particular port. So we know that this is a Spring Boot app that runs on the 8080, but I could make Docker expose that in my local host, so it will open like a tunnel from my local host port to the container. So for example, if I say 9090 8080, what it's going to tell Docker is if I go to in the browser and I say localhost 9090, then go to the container and open port 8080. So we're going to test that. And then the name of the image, books app 0.0.1. Okay, so hopefully now, as you can see, the container has started and I have a Spring Boot application running in port 8080 on a container. That's great. So now I can actually test this. So what happens if I go to 8080? So it doesn't work. So if I go to localhost 9090/books, and there it is. So you saw how quickly the container started, right? It's just amazing. I'm looking at the questions. There is, do you have to always build the application, also the modules? So you don't really have to build the application all the time, but so let's say you want to generate an image, you first need to build the application and then you need to build the image. But once the image is built, you can stop it and reuse it as much as you want. Look, I'm going to stop it now. And I'm going to start the same image, but now in port 7070. Okay. So now it started in 7070. And if I go here, 9090 doesn't work. 7070. And there it is. You see? Very, very useful. So that is how we can build images. And there is so much more that you can do. You can, for example, let's say our application takes some parameters, right? So in that case, you would, so environment variables, for example. So you can declare environment variables like this. Let's say variable 1, right? Usually they're like this. And you can establish a default value for this. And then any user that wants to override this, and then I can use it here. For example, I could add a variable here saying variable 1 and like that. So Docker will you can use these variables so that people who run the image can customize that image, right? So that is very useful when we run Spring Boot applications, for example, that take a lot of variables and so on, environment variables. I see a comment saying, so do you have now 2 containers ports? I mean 7070 and 9090. That's a good question. I don't have 2 now because I stopped one, but I could have 2. For example, now this is running on 7070. So I'm going to start another one on port 9090. Okay. I hope my laptop handles it, can handle it. Because sometimes when you run a lot of containers, it can take, and I'm streaming at the moment, so it can take a toll on the laptop. So now I have this one on 7070 and I can do localhost 9090 books, and it's also there. So I have 2 containers running, and you can see those containers by doing Docker container ls, and now you can see all the containers that I have running on my application. It's really easy to monitor your containers. You can actually, so in here we are running the container so we can see the logs here, but you can also connect to the containers and see the logs from there. IntelliJ has great tools to connect to containers. For example, but you go here, if you have the IntelliJ Ultimate Edition, you will be able to see the containers here. Here's one of the containers. I didn't add any name to the container, so Docker creates these random names. You see? So I have these containers here, and I can connect to the containers and run commands as well with terminal here. And another way to monitor if you don't have IntelliJ and you don't want to do it from the terminal, which is not bad, but you can also use Docker Desktop, right? So you'll see, let's see if I can open it. And if I go here, here are my containers. And here you'll see the logs of the container. So it's very easy to monitor also from here. So yeah, you have a lot of options to test and to monitor your containers. I have another question there, which is saying, can a database, MySQL, be added to a container? Absolutely. You can absolutely add I mean, you wouldn't have a single container where you have, for example, an application running. So let's say if you mean you want to add MySQL into this container, you might be able to do that, but I don't recommend that. The best way to run this would be in two separate containers, right? So you'll have a MySQL container and you'll have a Java application container, and you can connect both of them so they can talk to each other. And we will see more about that in the next session, which is about Docker Compose, which is a way in which we can declare multiple containers which we want to run, and then we run a single file, and it will pull the images and it will configure everything, and it will run, let's say, 3-4 containers in the same laptop. And those containers will be able to talk with each other because they will be in a same Docker network. So it's amazing. But that is something that we will do in our next episode next Wednesday. But it's a great question. Thank you. Yeah, thank you for who was that? Rama. And then I have another question from Fernando saying, if I need to use Java version 17 on my project, can I work without this version on local machine with these configurations? Yeah, you actually can. I mean, I would strongly recommend you that you use you have Java in your local environment. But if you can't, or for some reason you don't want to, you can definitely use it. Like, for example, I could change this to Java 17, and I could start the container, and maybe I don't have Java 17, but because I have the container with Java 17, I can run my application. But it will take you more time to debug and all that. If you're actually doing development, I don't recommend that. If you just want to run the container, you want to run an image that uses Java 17, then yeah, by all means, you can use that. What else? Can you please how connect both container, for example, Java container with MySQL container? Oh, great question, Danny. And we're going to see that exactly that in the next episode of because we still have some things to do here. But let me go on here. So one of the things that I'll do is I'll stop these containers now because I don't want to keep using resources. We can see that now that I've stopped these containers, if I do Docker container ls, I don't have any containers running now. You see, no containers. All right. So now that what I'm going to do is so I'm going to push this container, sorry, not the container, the image, to my Docker hub. So for that, I would need to do Docker login, but I'm already logged in, so I don't think I need to do that. So I'll just do that. I'll just create a tag by saying Docker tag books app 001, and I'm going to say Matias Di Salerno at slash books app 001. This is the version, by the way. Whatever I put behind the colon is the version of the image. I can create new images with new versions. Okay, so now I created this tag, and now I'm going to push this. So this would be Docker push Matias Di Salerno slash books app 0.0.1. Okay, now with this is going to push to my Docker repository in Docker Hub. So if I go to Docker IO, let's Docker Hub TSD Salerno. Let's see if I can find it. What was the URL for this? Just bear with me a second. It was here. So here's my Docker Hub. And let's see if I can paste it on the chat as well, so that you can also look at my Docker Hub. So I pasted it on the chat. Oh, it's not. This should be Docker, and this should be books up, like that. Right, I need to log in. I don't remember this. Just bear with me, guys. But it should be fairly simple. Just a second. So I'm logging in now. It's not working. Oh, because it's not that. Like that. Right. So now it works. Sorry about that, guys. So in here, you will be able to see all my repositories. So I'll paste this here. I see some questions. Let's see what's going on. How do you usually work with different environments such as dev, test, prod? Do you use different Docker hubs? Um, it depends really on what you refer to different environments. Like usually there is only one centralized Docker image repository. For example, and that depends on which kind of project you're working. Like if I'm working with a client here in Globan, usually, not usually, almost every time we're using the client's own private Docker hub, Docker repository, image repository. So the client would have their own image repository, a single one, and we would push the images there. Now, the same image can be used for different environments. So we don't really need to have multiple hubs for this for different environments. We can have only a single uh, image repository, and then we just use that one, and we just send the same image to different environments. All right. Someone is mocking me because I didn't remember the password. Yeah, that's right. All right. Um, so here's the last one that I created. So you can see we have a single version for this one, and you can actually, so you can see what this image has, and then you will also be able to you will be able to pull this image if you want. So if you copy this or if you copy exactly this and then you put a 001 here, you will be able to uh, immediately access this image, and you will be able to run it in your local. So that is a very cool thing. Um, all right. So now that we have everything in our repository, what I want to do, and if you guys want to try this on your own, you can actually try and pull this image and see if you can run it. That would be cool if you can do it live. So I'm going to have here, I'm going to log into Azure. Okay. I'll have to just give me a second because I'll have to um, authenticate. So just bear with me a little bit. I've lost the page. Okay, here it is. Right. So I'm going to authenticate to Azure. Oh, it seems like I'm already there. I'm authenticated. Okay. I'm going to create a new container app. So a container, you can see I've already been playing a lot with Azure lately. But I'm going to create a resource here, and I'm going to create a container app. To create a container app, I just go here, and don't worry, as I told you before, you don't really need to have Azure, an Azure account. This is just to show you how I can use Docker Hub to run this application anywhere. So I'll put create container app. Okay. And this could fail because I've been doing this quite often, but sometimes I can mess up. So I'm going to call this books up Docker for our test. And So in here, this is my subscription. This is the test group. This is a way to group different resources that you use in uh, in Microsoft Azure. So we don't really need to worry about this a lot. Now in here, this is the key part. So we're going to unclick this where it says use quick start image, and we're going to tell Azure to use Docker Hub as our registry. We're using a public. So here we have to put the name of the tag, which was here. So it's, come on, here. I'm copying this. I'll put it in Azure, and the version 0.0.1. I'm not going to override the command. You can override the command in that runs the application, but I'm not going to do that. And then this is telling Azure how many resources I want to give to this container. I'm going to keep it very, very simple. These default values. I don't want to do anything crazy with this. And something's going on with my camera. Just give me a second. Something's happening with the camera. Just give me a second. Right. Sorry about that, guys. Something was going on with the camera, and but I was able to fix it. All right. So what do we do now? All right. So we were with Docker here. So we don't do anything here. So we just tell container app where the image is. So next, we don't do anything here. We enable an ingress, which is a way to tell that I want to be able to access this from anywhere in the internet. So the ingress type is going to be HTTP. Transport. This is fine. Port. Let's just put 80. No, I think it's 8080. I think that should be it. Is there anything else that I need to? Accept traffic. Sorry, I need to do that here as well. Accept traffic from anywhere. Applies if internal setting is set to false on the container apps environment. Right. So I think now this is going to see if everything is fine, and now it passes all the checks, so I can create the application. Is there any questions here? No questions. Right, so the application is starting. You can see here there is like a Okay, application successful. So if I go to the resource here, I should be able to see a URL that Microsoft created for me. So here's the URL. I'll copy it and I'll say /books. And ta-da! We have our application running in the cloud for Microsoft. And I didn't have to do a lot of things. I just added the image name and that's all. So what do you think about that? I actually think this is really cool. This is a way to deploy an application very quickly in the cloud. And this container apps tool is really useful because it allows you to, it will automatically increase the amount of containers depending on how many users the application has. If a lot of users are trying to use this application, then it will start increasing the amount of containers so that it can handle the load of users. So very, very cool stuff. So this is what we did. We created the Docker file. We created the image. Then we run the image in our local environment. Then we pushed it to Docker Hub. And finally, we run the application in our Azure Container Apps environment. So Danny is saying, is Azure pay? Yeah, well, you have a free tier, Danny. You can use for testing and a little bit things there, and but it usually is paid. So if you actually want to have an application running that a lot of people will consume, then that will consume memory and CPU. So Microsoft will charge you for that. And there are ways that you can establish limits on how many people you want how many CPU you want to consume, and so on. So you have what you call a free tier, which is very limited for testing, and then you have a paid tier, which is, it could be whatever you want. Like, it depends on how much you use it. So I hope that clear your question there. I don't know if there are any other questions. But in the meantime, in the next episode, we are going to be using Docker Compose to orchestrate multiple applications in our local environment. So we will have a Spring Boot application. We will have a MySQL database and Kafka, all running in our Docker environment, and you will see how easy it is to test without having to install these applications, MySQL or Kafka and so on. So yep. There's another question there by Danny. Is saying, can I do all of that free? What I just did, you can do for free. Yes, you can do it for free. You can test and play around like that. You will have to put your credit card though before doing anything, because and you can configure Microsoft to tell you if they are going to charge you or not, so that you don't get charged. But it's so be careful with that. Some people end up spending a lot of money without noticing, because they didn't pay enough attention to what they were doing. So I'm not recommending any of you to go and go crazy with this. Be very careful and bear in mind that you can have issues if you don't use it properly. So be very careful. Always check that what you're doing is free. that you can use it and so on. So there's another question there. Are you going to talk about test containers on the next episode? No, I'm not going to talk about next test containers, but there was a YouTube. So last Java Code Camp, I did a whole session on test containers, and there was another session where I used test containers for refactoring an application. So if you want to see that, check out the old Java Code Camp, where you'll see how we can do all that. All right. I don't think there are any other questions, guys. So this was great. This was amazing. I always appreciate doing this and taking this time with all of you. So if you liked if you like what I do, you can subscribe to my personal YouTube channel as well. You can check out my personal channel, Programming with Mati. You can check out all the content we're doing with Globand as well, the old Java code camps. And next week, I'm going to be waiting for all of you to work with Docker Compose. So thank you for joining. Thank you for staying until the end. And I'll be seeing you next week. Bye, guys.